Class, let's knock out this homework. It says complete problems 1 through 8, 13 through 20, and 23 through 26. Identify the characteristics of the quadratic function and its graph. So if I'm identifying this, I know that my vertex is going to be at 1 and -1, okay, because the vertex is where my arch turns, okay. Let's see. I know that it crosses y at -2. It has no crossing at x-axis at all. I know that, well, according to this, y will always be negative no matter what, okay? So no matter what x is, y will always be negative. I also know that as x grows to infinity, or x goes to negative infinity, y will go to negative infinity. As x goes to positive infinity, y will still go to negative infinity. All right, so here we go. The vertex is 1 and -1, like I said. The axis of symmetry is x equals 1. Okay, then it says, let's see, the domain of all real numbers, the domain is all real numbers because it goes forever in each direction. The range is y is less than or equal to -1. So anything less than or equal to 1 would be the range, or -1 would be the range. And then the function is increasing when x is less than 1, right? The function I said would be increasing when x is less than -1, right? Going to be, let's look at this again. The function is increasing when y, the function is increasing when x is less than 1. So it's going up when x is less than 1, and it's decreasing, right, going down when x is greater than 1. The y-intercept is -2, stated that, and the function is negative for all real numbers. So no matter what x is, y will always be negative. Y is also going to be greater, I'm sorry, as y goes to negative infinity, x can go to negative infinity or positive infinity, okay? Number 2 is for you to do. Identify the characteristics again. Well, my vertex is going to be -8 this time because this is 4, this must be 2, this must be 6, this must be -8. So my vertex is a -8. My x-intercepts are going to be -4 and +4. I know my range, or my domain is all real number, and my range is going to be all numbers that are greater than -8. All right. I know as, let's see, numbers will be, let's see, this will be decreasing, so y will, excuse me, it's going to be decreasing when x is less than 0, and increasing when x is greater than 0. I also know that I'm going to have my y, let's see, when x is greater, or when x is less than -3, right? I'll have positive numbers for y. When x is greater than 3, my numbers will be positive. When x is less than 3, my numbers will be, x is less than, I'm sorry, less than 4. I forgot that these are actually going to be 4 and not 3. Then this is going to be less than 4 and, or greater than 4 and less than, greater than -4 and less than 4. My numbers will be negative. And as y is decreasing and going to infinity, sorry, it's y is going to infinity, x is going to be positive numbers, right? And as x is going to positive infinity, y will also be going to positive infinity. So there we go. The vertex was 0 and 8, or -8. The axis of symmetry is 0, right? Right through here. The domain is all real numbers, right? Because he's going forever. The range will be numbers that are greater than or equal to -8. The function is decreasing when x is less than 0, right? Decreasing when it's less than 0, increasing when it's greater than 0. The y-intercept is -8, right? The x-intercepts are -4 and 4. The function is positive, right? It would be positive when the x is either less than -4 or greater than -4, right? Or greater than 4. And negative when it's less than or greater than -4 and less than 4. And like I said, the y-intercept as it goes to positive infinity, right? The y will go to positive infinity, whether x is going to negative or positive infinity. All right, number 4 is yours to do. Next it says compare the graph to the graph of f of x when x is x squared. When I do this, I have to remember the rules. If the number in front is bigger than 1, this would be a vertical stretch. Now, the book will have you go ahead and plug numbers into the table like -2, -1, 0, 1, and 2. Then you'll say, well, if x is -2, -2 times -2 is 4. 4 times 6 is 26. If x is -1, -1 times -1 is 1, and 1 times 6 is 6. If x is 0, 0 times 6 is 0 times 0 is 0, and 0 times 6 is 0. If x is 1, 1 times 1 is 1, and 1 times 6 is 6. If x is 2, 2 times 2 is 4, and 4 times 6 is 24. Now that I realize this, I'm plugging in my numbers here. I see the x squared, so if I was going to write that in x squared, I would say, well, when x is -2, then y will be 2. So when x is -2, and this would be -2 here, right? Then y will be 2. Remember, this is 6, so this has to be 3. So this has to be a 4 right about here, which means on the other side for 2, it would be here. If x is 1, 1 times 1 is 1, so if this is -2, this would be 1. But if this is 3, then 1's going to be somewhere down here. Oh, sorry, about right there. Okay, and probably about right here. All right, and now you see the parabola is, I'm sorry, I'm having to do this with a mouse. It's going to be a little bit sloppy here. There we go. The parabola is going to be curved this way, which tells me this is getting higher. And it's almost like when you stretch your arms up, right? This is a stretch. So as you can see here, the graph of G is a vertical stretch by a factor of 6. Okay? All right. All right, number 6 is for you to do. This one says 1/4 x squared. So that tells me this is less than 1 but greater than 0. This will be a vertical shrink. A vertical shrink. So we can plug on all these numbers again, get our answers again. If I was to go ahead and plug in the original, remember, if x is 2, then y will be 4. So over here, well, I'm sorry, -2, then y would be 4, which means when x is 2, y will be 4. When it's 1, it'll be 1. So this would be 1 here since this is 2. This would be 1 here. As you can see now, when I'm making my parabola, it's still going to go through 0, 0. But you can see the arches like this, which means your line is going down, right? It's not going up, it's shrinking from the x-axis. So this is why we call this a vertical shrink. Now, I'm going to try to find my dot again here. I think I've lost it. There it is. A vertical shrink by a factor of 1/4. All right, you have number 8 to do. Number 13 says compare, this time I've got y equals negative 4x squared, and they're saying y equals 4x squared here. Instantly, what I notice is the negative was here is not there anymore. So since all the signs are going to become the opposite, this would be a reflection, okay? A reflection off the x-axis. So both graphs have a vertex of 0, and I'm just going to work this out. If this was here and this was 2, then 2 times 2 is 4, and 4 times negative 4 would be negative 16, all right? But let's work at some numbers here. Let's try 1. 1 times 1 would be 1. 1 times negative 4 would be negative 4. So this would come down the opposite, as you can see, down here towards the negative 4, right? And then steadily progress to the negative 16 that we talked about before. This is a reflection off of the, or in the x-axis. Okay, number 14 is yours to do. First time I got negative 4 and still negative, so that's not a reflection. But I do say this is an increase, right? An increase. So since 16 is bigger than 1, this is an increase by a factor of 16. All right, so it's a vertical stretch, right? When it's bigger than 1, it's a stretch by a factor of 4. Okay, and we know that because 16 divided by 4 is 4, right? The graph 8, yeah, there we go. Negative 16 is a vertical stretch by a factor of 4 of the graph negative 4 x squared. All right, so if we were putting this one together here, let's see, if I was to make a table, when x would be 2, 2 times 2, well, that's too big a number because it doesn't go that far on the graph. Let's try 1. 1 times 2, or 1 times 1 would be 1. 1 times negative 4 would be negative 4. So when it was 1, it would be at 1, 2, 3, 4, right? And so you see how this is going to be a stretch, right? Because the other one, the original one, came like this. Oh, my parabola is super ugly. But I think you guys see where I'm going with this. Okay, it's stretching downward, so that's a vertical stretch. All right, number 16 is yours to do. Now we have number 17. Let's see, it's saying describe the transformation from the graph of f to the graph of g, well, from f to g. We see x squared, and then we've got 3f of x. So this means this is a vertical, this is a stretch by a factor of 3, right? A stretch by a factor of 3. Vertical stretch by a factor of 3. This one actually shows you the original one, x squared. Okay, so this is x squared right here, right? And then when you increase by a factor of 3, do you see how it goes higher, like almost like you're taking your arms from the side and stretching them higher up in the air. So we call this a vertical stretch. Number 18 is yours to do. Number 19 has negative 1/5, but then it has negative 25. Now, please don't misunderstand. We don't have negative 25 being in place of that, okay? We have it in front of it. So this is our f of x here. This is going to be a vertical negative number. This is already a negative number, right? So this is going to be stretch by negative, let's see, I'm sorry, 25, a factor of 25, and I believe because it's in front of it, it's going to be a reflection. Let's see here. Very good. You see here, because this is not 25 in front of x, okay, like this number is in front of x. This is in front of f of x. So this is the negative going on to the negative. So this is going to turn this completely in the other direction to be positive numbers, okay? And then it's a stretch by a factor of 25 because this 1/5 was here. So we're increasing the original one by 25, and that's going to stretch it up much higher. All right. Number 20 is yours to do. So let's describe and correct the error in graphing and comparing f of x equals x squared and g of x equals negative 0.5x. So what we have here is a number that's, one, it's negative, so that's going to be a reflection. And two, this number here is less than 1, but greater than 0. So this is going to be a shrink. So they said here the graph have the same vertex and the same axis of symmetry. The graph of G is a vertical stretch, it says, by a factor of 0.0 or 0.5 and a reflection. The reflection was correct, but this is not a stretch. If it's less than 1 and greater than 0, this should be a shrink. So since negative 1, since negative 0.5 is between negative 1 and 1, the graph is a vertical shrink, not a vertical stretch, okay? It was a reflection, though, but it was a shrink instead of a stretch. You have number 24 to do. I'm going to move this out of the way so you can see it well. All right, let's go to number 25. It says the table represents a quadratic function. Graph the function and identify the characteristics of the function and its graph. Well, if I was going to go ahead and graph this, I'm going from here, right, to here. Noticing the numbers are becoming the opposite, right? They're turning in a positive number. So I know there's going to be a, excuse me, a reflection there. Okay. I'm also going to notice what looks like maybe, let's see, we've got when x is negative 4, and y is 15, 3 is 16. So I see that negative 3 here goes here, and negative 1 here goes here. So graph the function and identify the characteristics. Well, if I graph this function, all right, when x is negative 4, okay, x is negative 4, it said that y was going to be 15. 15 is about right here. When x is negative 3, since this would be negative 2, negative 3 would be here, then y would be 16. Okay, so that tells me the vertex is 16, or actually negative 3 and 16. Then it says we got x is negative 2, then y is going to be 15. And then we see that we have negative 1 and 12. Okay, so when x is negative 1, y is going to be 12. And when x is 0, y will be 7. So this tells me a few things, just now that we made it. My vertex is going to be negative 3 and 16. It crosses my x-axis at, well, it looks to me, well, this is going to be, when x is, let's see, if this is 4, and this is 8, this must be 6. So this is probably 7. Okay, it crosses it at 7, it looks like 1. Okay, and that makes sense because it was at 0 and 7, it's decreased to 7, yeah. 7, 1. Okay, so we're seeing here that exponentially, right? It's going down. So we have, what other things can we say? The y-axis is going to be 8. We can also say that when x is less than negative 7, okay, when it's less than negative 7, all my numbers will be negative. When x is greater than 1, all my numbers will be negative. But when x is greater than negative 7, greater than or equal to negative, well, no, greater than negative 7 and less than 1, then all my answers will be positive. I can say that my parabola is increasing for numbers when x is less than -3, but when it's greater than -3, then all my numbers would be decreasing. My parabola will be decreasing. I can also say that when my y is going, when x is going to -infinity, y is going to -infinity. When x is going to +infinity, y is still going to -infinity. And here we go. The vertex is -3 and 16, just like I said. Axis of symmetry is -3. The domain of all real numbers, right? So the domain's going to go on forever. The range is going to be less than or equal to 16, right? The function is increasing when x is less than -3, it's increasing. When it's greater than -3, it's decreasing, right? Going down. And the y-intercept is 7. 7. The x-intercepts will be -7 and 1, just like I said. The function is negative for, let's see, the function is negative when x is less than -7, okay? And it's greater when it's positive. So when y is heading toward the -infinity, x would be -infinity or +infinity, right? All right, let's see. Are there any others for me? Nope, that was it. All right, guys, the rest were for you to do. I'll see you in class for lesson 8.2. Have a great night. Good night.